Welcome students. Today we'll be starting heat transfer. Heat transfer heat transfer comprises of mainly the modes by which the heat can be transferred from one body to another. As we know that heat is the form of energy which is transferred from one body to another body when the temperature of one body is higher than the temperature of other body. So it is a form of energy. Here we'll be talking about the mode of heat transfer. So in GATE syllabus, heat transfer accounts for 4 to 7 marks, which is a good amount of marks which you can attain by studying heat transfer. It's a simple topic but requires plenty of understanding. So in heat transfer for GATE syllabus, basically we have conduction, we have convection, we have radiation, and heat exchangers. These are the major topics from which we have to study. Okay, so let's begin with the conduction. So conduction is a process in which when two bodies or there is a temperature difference. Let us take an example. If I have a body as shown in the figure and temperature T1 is maintained at one end, T2 is maintained at other end. There are two ends and T1 is maintained at one end, T2 is maintained at one end. There will be a heat transfer from T1 to T2 if I say that T1 is greater than T2. Now people have conducted experiments, and on the basis of experiments they found that heat transfer rate, this is a term which we'll be using throughout, heat transfer rate, as the name suggests, the rate at which heat is transferred, denoted by Q, the unit will be watt. So heat transfer rate, which is nothing but the energy joule per second, that is the energy flowing per second. Heat transfer rate is proportional to temperature difference, that is delta T, by the distance, del X, and also proportional to the area of cross section. This is cross sectional area, or area perpendicular to the heat flow. Now combining these, obviously I would like to add a negative sign here as well. The negative sign is denoting that temperature is decreasing with delta X positive. So as we go in this side, the temperature is obviously falling from T1 to T2. So delta T by delta X has to be negative. So this comes out to be A delta T by del X, a negative sign. Now further, when I write to remove the proportionality sign, I put Q is equals to minus Ka delta T by del X. This law, or this derived from the phenomena, that is from the experiments, is known as Fourier's law. In differential form, that is when delta X tends to 0 or very small, I can write Q as minus Ka dt by dx. Now here term K is defined as thermal conductivity. So it is the property of substance.